AC for some subject chemistry. Topic determination of do in a water sample, lake or river water, and compare the DOS to different samples. Determination of do in a water sample found lake or river water and compare the DOS to different samples. Determining dissolved oxygen do water samples is a key indicator of water quality and ecosystem health. The two primary methods for measurement are the Winkle titration method and using a dissolved oxygen method. Methods for dissolved oxygen determination. Method 1. Winkle titration. Iodometric method. This classic chemical method is highly accurate and is often used as a calibrate to do meters. It is a one-time measurement best performed in the field immediately after sample collection to private atmospheric oxygen for an alternative result. Procedure. Sample collection. Carefully fill a glass stoppered bottle BOD bottle completely with a water sample, ensuring no air bubbles are trapped inside. Fiction had a magnesium sulfate solution and an alkaline iodide isot reagent. Using a PPT placed just below the water surface stopper, invert the bottle several times to mix. If oxygen is present, a brown precipitate will form. Acidification. Once the precipitate settles halfway, invert again then and connect contracted sulfuric acid just above the surface of liquid stopper. Dissolved, which point a sample is fixed and can be stored a few hours in a cool and dark place if needed. Titration. In a flask, titrate a specific volume of the fixed samples with a standardized sodium thiosulfate solution. Minute it is turn a pale straw color. Endpoint. Add a few drops of scratch indicator solution which will turn the solution deep a blue. Continue titrating drop by dropping until the blue color disappears completely. Calculation. The amount of titration used in a milliliters directly corresponds to concentration in milligrams per liter. Method 2. Dissolved oxygen method. This method uses an electrochemical or optical sensor connected to a meter, providing quickly real-time digital reading in the field. Procedure. Calibration do meter according to the manufacturer's instruction, usually involving air or zero oxygen solution. Measurement. Place a probe into the water sample or directly into the water body. Ensure the water is moving past a sensor. If using electrochemical probe that consumes the oxygen to get an accurate reading, optical sensors less flow independent reading. Once a reading stabilizes, record the do concentration in mg L or ppm. Comparison of do in a pond and river water samples. To compare do levels, follow on the method above for which water source, taking a multiple samples at the same time day for consistency. General observation. River water generally has higher dissolved oxygen level due to constant momentum flow and erosion, which partially oxygen diffusion from the atmosphere. Found water topical has lower and more variable do levels, especially near the bottom. Still water is less aerated and decomposition of organic matter by microorganisms can consume larger amount of oxygen, particularly at night or in deeper layers. Do level below 5 mgl considered stressful for most aquatic life, while level below 3 often too low support fish. Features. Rivers found lakes. Water movement flowing and turbulent, still or slow moving water. Aeration. High re-aeration due to atmospheric mixing as a water flows over rocks and obstacle. Limited atmospheric diffusion. Oxygen may be lowest at the bottom due to the decomposition. Temperature fluctuation. Generally cooler and less susceptible to rapid temperature changes than shallow ponds. More susceptible to temperature variation. Warmer water hold less oxygen. photosynthesis decomposition. After the moderate plant growth, decomposition occurs but is less likely due to cause energy condition due to movement. High plant growth can do supersaturation during the day, but decomposition by bacteria at night can rapidly deplete especially at deeper levels. Typically, do levels generally higher. Typically, two levels generally higher do levels often above the 6.58 mgl for a healthy system. More variable can range for very high a very low NXC at a night bottom depths. Conclusion on a dissolved of oxygen level. The determination of dissolved oxygen in different water sample allows comparison of their water quality and capacity. A support aquatic life. River water do level in generally highest in river water. The constant movement of flow over acts and large surface area exposed wind fast efficient absorption of oxygen from the atmosphere. This tribulation oxygen rich surface water, deeper water leading to more uniform and higher concentration. Pond and lake water. The dew levels in a pond or lakes are typically lower and more variable. Stratification. Still water has less surface aeration than flowing water. Stratification. In deeper lakes, thermal stratification can lead to oxygen for condition in deeper layers due to decomposition process or bottom or consumer oxygen. Plant activity pollution. While the plants procedure oxygen during the day, decomposition of oxygen, excessive organic matter by the bacteria consumed a significant amount of do leading to low level, especially at a night or heavily polluted atmosphere system. Reference Vulgar quantity in inorganic analysis Pestes Advanced Practical Chemistry Jagandam Singh. Thank you so much.